Have you ever wondered why ice is slippery when you walk on it? How about how wind is created? Or even how clouds form? Today, we're breaking down how the weather works through fun science experiments you can try at home. This winter we have seen a fair share of freezing rain and ice events, and each time, meteorologists have expressed the dangers of slipping on ice. We all know that ice is slippery, but do we know why? Here in this experiment, we have an ice cube lying on top of a bottle of water. Now, we also have a wire, and attached to the wire are two mugs which act as weights. Now, as we put the wire on top of the ice cube, the pressure from the wire pressing down on the ice cube, well, it melts the ice. That's because high levels of pressure can melt ice when applied on it. So here we'll see the wire seep through the ice cube. So essentially, when we walk on ice, we are applying our body's pressure onto the ice, which therefore melts it. And when we melt that ice, it's basically like we are walking on a thin layer of water, and that will cause you to slip. We've all experienced strong winds at one point or another, but have you ever stopped to think about why these winds are occurring? Here we have an experiment that explains just that. On the left, we have a tray of sand that is very hot because it just came out of the oven. Now, what do we know about hot air? Hot air rises. So we see that hot air rise, which takes the atmospheric pressure and it lowers it because you have the air particles lifting off of the surface of the sand, lowering the pressure at the surface. Now on the right, we have a tray of cold ice cubes. Now, what do we know about cold air? Cold air sinks. So we're having a lot of air molecules layering on top of these ice cubes, which is increasing the atmospheric pressure at the surface of those ice cubes. So how do we know wind is forming between these two surfaces? Well, basically in general, pressure is always looking to balance itself out, as most things do in nature. So we see the high pressure over the ice cubes, but the low pressure over the hot sand. Now, the pressure will want to balance out, which means the high pressure over the ice cubes, those air molecules are going to want to push across towards the low pressure above the sand molecules. Now, we can test this by taking an incense stick and lighting it with a match and then putting it in the middle between the two surfaces. The smoke from the incense stick is moving towards the sand because that is showing how the air above the ice cubes is heading over towards the air above the sand because it's balancing out pressure. It's balancing out the high pressure above the ice cubes to the low pressure above the sand. And we can see based on the smoke, the air is moving towards the sand, and that is how wind forms. When warm air rises, creating low pressure systems like what we saw with the tray of hot sand, that rising air eventually gets high enough to the point where temperatures are cold enough for that water vapor to condense. Now here we have a 2-liter bottle with some alcohol, duct tape, and a bicycle pump. Now essentially what we are doing here is we are adding rubbing alcohol, which is acting as our water, into the bottle. Now rubbing alcohol evaporates very quickly, which will accelerate our condensation process here. So right now there are many gaseous rubbing alcohol particles inside this 2-liter bottle because they have already evaporated. Now what we are going to do now is add pressure after we add a little bit of tape here to hold in the air to the bottle. Adding pressure will increase significantly the temperature inside the 2-liter bottle here. Now with that increase in temperature, when all the air gets let out, the temperature inside the bottle will decrease significantly thereafter. So let's here make a hole in the top of this cap here, and we're going to apply the hose to the bicycle pump to the cap. So now we are going to add pressure into this bottle here. And currently we are seeing the temperature inside the 2-liter bottle significantly increase. And now the significant increase in temperature in this 2-liter bottle is going to mean that when the air escapes, the temperature will significantly decrease from the bottle. And that significant decrease in temperature will immediately condense many of these alcohol particles currently in a gaseous state in this bottle. 3, 2, 1, and there you have it, guys, a cloud.